refers to the major activities in the course of the product's lifespan, from its manufacture, use and maintenance, to its final disposal, starting from the raw materials acquisition required to its manufacture. So you can see in the picture that is a cycle which starts from raw materials, then go through material processing, staging of manufacturing, then there is the assembly phase, the distribution to customer, the use by customers, and at the end of its life, which could be recycling or disposal or reused of it. As you can see, this is a way to study and to provide a comprehensive point of view of all the environmental aspects of the product or process life cycle, and to study all the impacts, the environmental impacts during its life, and give a more accurate picture of the true environmental trade-offs in product and process selection, because it's not a good strategy to focus only to one process, which usually is relating to the industrial point of view, but it's correct to analyze. I'm just reading the chat. To analyze the entire process. Usually the LCA follows international rules, which is contents inside the ISO 14040, which is an international standard organization. So there is a standard which gives the rules to follow. So an organization couldn't do what it wants to do, but just to follow all the rules that everyone can follow to make a correct study. From this picture you can understand that you should consider the process product system starting from the supplier's one, then there is our company, and then there is the phase of use and end of life of the product. This process needs input from the environment and gives output. Every phase needs input such as, for example, resource extractions, and gives emissions and waste to the environment. To quantify this kind of impact, you should choose some indicators, some categories of indicators, just to quantify the impact and to make a comparison between two products or among more products. I like pictures. So you can see there is here there is the life cycle of our product, which starts from extraction, then there is processing, maybe there could be design, manufacture. So this is the firm. Then there is the distribution phase, transport. There is the use, the repair phase, and at the end there is the disposal one. Through all this chain, there are inputs, which are raw materials, energy and water, which are the resources. Okay. And there is waste to the environment, and waste means waste itself, but even emissions to air and emissions to water. I saw that there are some attendants which are entering now the meeting, and I'm just saying what is LCA analysis. You can understand, I mean, this slide summarizes what I said in these 10 minutes. That is that life cycle analysis starts from extraction and ends with the disposal of a product. And through all these phases, there are input from environment and output to environment. And making an LCA analysis, you study all this system, right? One can ask to himself, which is the reason that pushes or encourage a firm to make an LCA. There are many reasons. First of all, calculate a product's environmental impact. Then identify the positive and negative environmental impact of a process, because an impact could be usually we think about an impact as a negative one, but a product could have a positive impact. For example, let's think about wind farm, which produces energy from wind. This kind of process has negative environmental impact, but even positive ones. Then we can find opportunities for process and product improvement, because studying all the life cycle, products life cycle, we can identify which is the process we can improve because of, I don't know, it needs a lot of energy or water, and so we can focus our efforts to a specific process. We can compare and analyze several processes. Further, I try to give you some examples of LCAs between two products, or more than two products, and so we can compare which are the different environmental impacts. Then we can quantitatively justify a change in a process or product. So if an organization has to decide to change some process, he has a quantity reason, and then this is linked with costs. So an organization can do the right choice. Then we can improve product itself or corporate image. So this is a reason linked to marketing field. Then we can answer customers' requests for environmental and social information, because we know that customer is becoming more and more demanding. A customer wants to know which is the environmental impact of a product, and so he can choose between two products and choose the one with less environmental impact. And then, as I said, identify cost savings. For this kind of reason, there is a particular kind of LCA which is defined LCC, so which means life cycle costing, which links environmental impact with costs for example, reducing this kind of impact. What LCA aims at? LCA aims to understand the flows of matter and energy involved in the product, material, manufacturing process, packaging, etc., and aims to find out what are the environmentally critical points. The final aim is prevent and remove them maybe using other materials or other systems. It's not a good way to explain the topics because I don't know if you are follow me, but anyway, I hope so. Anyway, normally this kind of study, LCA, is called from cradle to grave. But you can change if establishing the study from cradle to grave, from cradle to gate, from cradle to cradle, from gate to gate, and from wheel to wheel. Let's explain every voice, right? So cradle to grave means that you study a full life cycle products from resource extraction, which is cradle, to use phase and disposal phase, which is its grave. But you can change also to study a product starting from. No, I'm sorry. Power. Wait a moment, please. Pronto? Mi senti? E per lo schermo? Lo schermo? Lo schermo? Roberto, can you see my? Okay. Mi senti? Sorry about that. In Italy we said il bello della diretta. In Italy we say il bello della diretta. I'm so sorry about that. My computer dead. Anyway, a company should choose to start from Credo and stop to its gate. This assessment is focused on a partial product life cycle from resource extraction, which is Credo, as we saw, to the factory gate, leaving all the other phases, which is transport and use and disposal. You can choose to start from Credo and to stops to Credo 2. This is a specific kind of Credo to grave assessment, where the end-of-life disposal step for the product is a recycling process. This method used to minimize the environmental impact of products by employing sustainable production, operation, and disposal practices, and aims to incorporate social responsibility into product development. And as we said, is used only to a recycling process and to quantify the impact in recycling process. Then you can choose to start from gate and stop to gate. This is a partial LCA looking only at your firm, at your company, and is focused on the entire production of the product inside the company without considering the chain, the total chain of the life cycle. Then there is a particular life cycle assessment, which is named wheel-to-wheel. This is used for transport fuels and vehicles. The first stage, which incorporates the feedstock or fuel production and processes and fuel delivery or energy transmission, and it's called the upstream stage, while the stage that deals with vehicle operation itself is sometimes called the downstream stage. Upstream and downstream are terms which are used in during an LCA. There is the upstream, which is referred to all the raw material process. The downstream, which includes all the process at the end, after the gate of a company, which is transport to consumer use and end of life. And then there is the core. This is the term used by researchers which study LCA, and with core the core is the term to identify the process, the industrial process, the process inside a farm, inside a company, inside an organization. So now we can answer better at the previous answer, what is LCA? Just summarize the answer. LCA is a tool for the systematic evaluation of the environmental aspects of a product or service. Through this LCA is studying all the stages of the life cycle of a product. Systematic evaluation, systematic because as we saw, is based on a ISO standard, which is 14040, and so all the rules are fixed. Is oriented to quantify environmental aspects, and the object could be a product, but even a service. This is a service is, for example, the object of our calculator. And okay, right, all stages. I think that now we can we understood what that means, which is all the that is all the phases from raw materials extractions to end-of-life processes. LCA is often termed as a cradle to grave because it starts from raw material and it finishes to final disposal of the product. It looks into all the processes, all the stages, and it considers environmental aspects and potential impacts of the process stages, considering all the inputs and outputs. We saw that inputs are raw materials, energy, and water, and outputs are waste and emission to air and water too. LCA provides analysts with quantity data. So the result of an LCA is a number to determine the environmental impact of a product or system, and which with this kind of data, with this kind of number, you can do comparison between two products or among more than two products. For example, with an LCA, we can identify what are the impacts of 9,000 tons of carbon dioxide or 5,000 tons of methane emissions released into the atmosphere. And we can answer this kind of questions. Which is worse? Is worse carbon dioxide or methane emission? And what are the potential impacts on smog of these two kind of pollutants? And which is worse for global warming? The indicators that I'm going to calculate with LCA have different impact if you are in, for example, in Africa or in Europe, in an industrial country, industrial European country. It's different if you are in Tokyo, which has which has a lot of smog, or if you are on a desert, let me say, right? So the indicators are numbers, but this kind of numbers have to be studied in relating to the places you are, to the market you are studying, and so on. But maybe I'm sure you are going to understand better with the example that we can see together later. LCA is a methodology behind some ecological labels that are used to communicate to the customer and to provide him with some environmental information. LCA is transversal to a lot of ecological labels, and I make some links, but I saw that I don't know why it's not working. Let's try. If it's not working, I'm ready to make you see in another way. Perfect, it is not working. Okay, I'm going to see you in another way. So here we are. Okay. It's really small. Okay, here we are. This is the first example. This is an EPD. EPD is a kind of labels, ecological labels. EPD means Environmental Product Declaration, and this is a kind of report a company chooses to use to communicate some information to its customers. But the methodology is the same, which is LCA, life cycle assessment. And as you can see, there is a presentation of the company and presentation of the product, which is the object of the LCA. Yes, my presentation again. And then there is a functional unit they have studied. And then there is the indicators that they have calculated through all the life cycle of this product, which is olive oil. This is boundaries of the system. As you can see, there is upstream, core, and downstream processes, and the company here explains which is the core phase, the extraction of the oil from the olives, waste management, the preservation of the oil, transportation to the packaging plants, packaging of oil, and the transportation of the raw materials and energy. The downstream phase includes the following process, which is transportation from the final production to a distribution platform, transportation to the retailer, waste management, the use of product, and the recycle and disposal of packaging. And then this is the boundaries of the system, the things that we are talking about 5 minutes ago. from where I start and when I finish to study. Then there is here there is the indicators, the results of all the study. So this is one kind of ecological label. I think that the last meeting, the last webinar is focused on this kind of topics. So I'm sorry, but I can't stop here and explain what is a EPD, but we can go through it later. I think in September. So let's close this one, and this is another example of ecological labels. My computer is really slow. Okay. We'll see. It's terrible, believe me. Oh, okay. So this is another kind of, I'm sorry, this is in Italian. This is another kind of ecological label. But the method is the same, which is life cycle assessment. This is the object of the life cycle assessment, and this is the indicator that result from the study. As you can see, this is the phases: cultivation, extraction, process of inside the company, transports, oil transports, transport of packaging, distribution, end of life. And you can see that the maximum percentage of indicators, which means environmental impact, is relating to cultivation phase. Another problematic phase is distribution, because of the emission produced by vehicles. And then there is another contribution from transport of other materials. So this is upstream, core, downstream. The phases I was talking about earlier. Upstream is cultivation, extraction of materials, of oil, olive oils, and production of packaging. The core process is all the processes which are using to produce the oil, and the downstream, which is distribution of products, eating, using the oil, and then the end of life. And so this is a way to communicate to your customer all the impacts relating to the production of an olive oil. So let's go again to the presentation. Okay, here we are. So LCA studying is a sort of identity card. I just put this label, which is nutrition facts. this is the labels you can find on a foodstuff, on a food product, which says to you all the fat, the cholesterol, the carbonated and proteins which are inside the product you are going to eat. And with the live LCA you can do this sort of label and maybe put it on the same product, and besides giving some information about the nutrition facts of that kind of product, you can say even environmental information, which is energy used to produce this kind of food, and all the resources, the raw materials used in a way of no virgin material, recycled compostable material, packaging, so materials to make the package, and then all the toxic substances, water you need, and social indicators, which means, for example, labor practices, fair trade, transparency. So with LCA you can give this kind of information to customer. So just one slide up, on the story of LCA. So its background. It first developed in 1960s, which were motivated by the economic struggles. Just for curiosity, in 1969, the first study about beverage containers was done. In the 70s and 80s, this analytical process became less popular due to lack of standardization. And so there was a need to find, to establish some rules to follow, because all the companies who wants to did this kind of assessment can did it with the same methodology, following the same methodology, and not doing what everyone wants to do, or things that is it was best to do. Now LCA has been standardized within 2 ISO, which is 14040 and 14044. And this kind of standard give some rules to follow. The process involved in LCA, as we saw in the previous slides, are input, so raw materials, energy, and water. Water is missing. The process are raw materials extraction, then there is a production phase, the production of a typical product, then there is the use and maintenance phase, and the end of life, recycling and waste management. All these phases produce outputs to environment, which are emissions and waste. So with raw materials, we consider all process and distribution steps required to produce the raw materials. For example, we are studying, I don't know, a paper packaging. So for raw materials, we are going to study cellulose and all the process to extracting it from trees. And then you need to make paper, you need water, you need some other substances, for example glue, and then you should consider the process to produce the glue. Then there is production, so all the process and distribution steps from where the raw materials is bought by the client until the finished product leaves the factory site. Then there is distribution, so all steps involved with moving the product from the factory site to the end consumer. And you can consider the kind of vehicles you choose to use. For example, tracks or trains, or maybe some materials come from Africa or from, I don't know, America, United States, using boats or using airplanes. So you should consider all kind of vehicles. Then there is the phase of use, which means all steps from end consumer purchasing goods through to disposal. And then there is a disposal, which can be landfill, so all the step from consumer disposing of product to reaching its final state of decomposition. And for recycled product, all steps from consumer disposing of product to reaching the recycler. And these phases come from the left to the right of the screen, because raw materials is cradle, the beginning, and disposal is grave, the end. As we said, LCA is standardized, LCA methods is standardized by 2 ISO standards, which are 14 and 40 and 14 and 44. The previous one gives principles and frameworks, and the second one gives requirements and guidelines. The most important one is 14 and 44 because of the guidelines that it gives. The guidelines, which means that are all the points you have to follow to make a correct life cycle assessment. It specifies the requirements on LCA that should be in compliance with its contents. And ISO provides the guidelines to conduct a life cycle assessment, which is the same for all the companies, for all the association, for all the researchers who want to make a life cycle assessment. And ISO specifies the goal and scope definition of your LCA, the life cycle inventory analysis phase, which is which kind of data you need, the life cycle impact assessment phase, so how to calculate the environmental impact of your product, the life cycle interpretation phase, so how to interpret the results, reporting and critical review of the LCA, Then there is a limitation relationship between the LCA phases and conditions for use of value choice and optional elements, which are less important than the previous one. So let's see the first voices, the first points. Goal and scope, LCI, LCIA, and life cycle interpretation. Just a slide about how is divided this standard. The standard is divided into 6 sections. One is scope, the second one is normative references, then there is terms and definitions, but the core of this standard is number 4, methodological framework. Then point number 5 is reporting, and then critical review. But anyway, the important section of this standard is the methodological framework. This method is divided in definition of goal and scope. Then there is, as we said in the previous slide, this one. Then there is inventory analysis, impact assessment, and interpretation, which is a transversal phases of all the others. Let's go through each of them. So what does goal definition and scoping mean? We have to define and describe the product or the process or the activity we are going to study. We have to establish the context in which the assessment is to be made, and we should identify the boundaries of our system. Do you remember the one, from cradle to gate, from gate to gate, from cradle to cradle? So the boundary, you are focused, and environmental effects to be reviewed for the assessment. This is a key step, the main step, because you start from this point, goal definition and scope definition. And the ISO standards requires that the goal and scope of an LCA be clearly defined and consistent with the intended application. What all these words mean? In other words, you have to identify the reasons to conduct the LCA. For example, I want to study the impact of I don't know, handkerchiefs, or a glass container. Sorry. Then you have to define the audience, your audience, which means to whom communicate the results. Because it's different if you have to communicate to university researchers, or you want to communicate the information to common consumer that has to understand all the numbers you have calculated. If the results should be, and then you have to identify if the results should be compared with other results derived from other studies on similar products or services. For example, we want to make a comparison between 1 liter of fresh milk put in a paper packaging or in a glass packaging. And I want to know which is the packaging with a bigger impact, environmental impact, which is better, or which is the part of the environment who has the bigger impacts from a production of paper packaging or a plastic packaging. Which are the steps involved in this phase in goal and scope definition? First of all, the product system you have to study. Then the functions of the product systems. So we have to define which are the functions. The functional unit, in a while you can understand why it is written in blue letters. The system limits, and then assumption, limitation, and data requirements that are a specific phase, especially assumption and limitations, that we are not talking about now because it's really scientific items, because assumption and limitations are strictly related to statistic fields. But I think that the important item to understand is how to identify functional unit. What is functional unit? Oh, just a bracket. Data requirements is important because you have to define in this phase, which is goal and scope definition, which are the requirements of your data. That could be primary data or data from literature. Primary data is the data that all the firms involved in the study can give you, and data from literature is database already existing inside the software that are used to make life cycle assessment. So we're talking about functional units. Sorry about this brackets I opened. What is the functional unit? So I'm going to read which is a definition given by ISO 14 and 44. But please don't be scared, because maybe some examples that we are going to see in a while maybe clarify the meaning of this term. Functional unit is a quantified description of the performance of the product systems for use as a reference unit. So when you start to make a life cycle assessment, you have to define your functional unit. But the functional unit is linked to the performance of a product, not only the product itself, but the performance of it. The functional unit describes and quantifies those properties of the product which must be present for the studied substitution to take place. These properties, for example, its functionality, its appearance, stability, the durability of a product, ease of maintenance, and so on, are in turn determined by the requirements in the market in which the product is to be sold. So let me go further, because the example is clearer. anyway, so there is a functional unit, and then ISO standard introduces the concept of reference flow. And what is the reference flow? Reference flows is a translation of the abstract functional unit into specific product flows for each of the compared system, so that product alternatives are compared on equivalent basis. If I have to compare two products, I have to make the basis to make this comparison. The reference flows are the starting points for building the necessary models of the product system. So the stepwise procedures is described for these elements of a product life study. I mean, the procedure to identify a functional unit and the reference flow is divided in 5 steps. You have to describe the product by its properties. The properties we saw 5 minutes ago. I mean, for example, durability of a product, or maintenance, or chemicals properties. Then we have to determine the relevant market segment. We have to determine the relevant product alternatives, if there is an alternative. In the examples I used earlier, I talked about fresh milk inside 2 kinds of packaging. So I describe the product and its properties. I mean, it's a fresh milk, for example, non-pasteurized milk. I defined the market segment I am referring to, and the alternatives, which means paper packaging or glass packaging. Then we have to define and quantify the functional unit in terms of the obligatory products properties required by the relevant market segment, and then determine the reference flow for each of the product systems. To determine object of study, we have to consider product properties, market segment, and product alternatives. To provide quantified reference, we have to define functional unit, and to provide equivalence of product system, we have to define the reference flows. Let's do we'll see some examples, and then coming back to the previous slides. I'm sure that maybe it's better. So we are studying, for example, and we said fresh and packaged milk. So we have to comparison this kind of milk and this kind of milk inside this kind of packaging. So this is the material which are inside this packaging: paper, plastic, and ink. In a packaging of 1 liter, there is 27.3 grams of materials. And then there is this plastic packaging, and there is a bottle which is in PET. Then there is caps which is in HDPE, and then there is labels which is in PP. this kind of plastic. In 1 liter packaging there is 30 and 27 grams of materials. Oh, sorry. So in this kind of example, which is the functional what is the functional unit and what is the reference flow? The functional unit is the quantity of fresh milk of some kind of quality, for example, entire one or without fat, intended to annual consumption of one person, liter just decide, packed in a packaging of, I don't know, paper or plastic or some other materials. This is our functional unit. Which is the reference flow? The reference flow in this kind of example is the quantity of product intended to satisfy the function of the functional unit. In our example, 600 containers of, I don't know, paper, each containing 1 liter of milk. This is another kind of example. Maybe a company wants to make an assessment, life cycle assessment on this kind of product to dry the hands, or this kind of products or this kind of products, and maybe this company wants to compare one or all this kind of system, dry system. The functional unit here is the identical number of pairs of hands dried, because the function of these objects is to dry hands. So my functional unit is identical number of pair of hands that has to be dry. The reference flow for each system could be the average mass of paper or the average volume of hot air required to dry one pair of hands. So I like this kind of example. And this kind of example is also inside the one ISO to maybe to, I don't know, say if carbon footprint or something, which is, I mean, clear, because you can understand which is the difference between a functional unit and reference flow. Functional unit is just the function of the product you are going to study, and reference flow is the quantity of this functional unit you have to study to reach, in this case, a pair of hands dried. Let's go in here. So maybe now it's a little bit easier to understand this kind of pictures. First of all, you have to describe the product by its properties, obligatory properties. For example, in the case of system to dry hands, the obligation property is just to to be able to dry a pair of hands, and these properties is useful to define the functional unit. Then there is the positioning properties and the market irrelevant properties, which is useful to define reference flows, your reference flows. Then there is step 2, which is determine the relevant market segment, because there is, in this case, 2 alternatives, the paper system and the air system. And you have to understand which kind of market segment you are referring to determine the your reference flows. Okay, so as you can see, all these steps are linked together, and in reality there is no clear boundary between all the steps. In fact, although the procedure is described in 5 consecutive steps, it may often be relevant to perform the procedure in an interactive or concurrent way. For example, the product properties described in step 1 may be determined at the same time information on the market segmentation. The product of the product alternatives, which are step 3, may be given in advance or thus contribute to the definition of the relevant product properties. So you can start, oh, here, okay. You can start from this kind of step to determine the properties of your product. Or again, the functional unit can be defined without having first determined the relevant product or the product alternatives. So this is, I mean, the philosophy of the procedure to define goal and scope, but to define functional units, but it's not so, the phases are not so divided, the one from the other. And just a reference to our calculator. For us, we are not. We are going to calculate OF, which is the topic of the last webinar. But anyway, there is no difference between unit of analysis and functional unit. In our case of study, our unit of analysis is one student or child or pupil registered in one school in 1 year. And we are intended to provide a measure of the potential pressures in terms of energy and resource consumption related to the service offered by schools. Let me do the comparison. This is the service offered by school, could be the functional unit of an LCA. And this one student registered in one school in 1 year, could be a reference flow, right? Let's start from the previous, let's start from the, oh, it's really, really sensitive. Previous slide. I tried to clarify what is goal and scope definition phase. Now we are going to talk about inventory analysis. What is this? Inventory analysis is the phase which should identify and quantify energy, water and materials usage and environmental releases. And literally, inventory means listing of products. And this phase is named LCI, Life Cycle Inventory, and involves creating an inventory of flows from and to nature for a product system, which is the things that we are talking about, I mean input and outputs. Inventory flows includes water, energy, and raw materials, and outputs like releases to air, land, and water. It also involves data collection and quantification of needed input-output data. To make a correct inventory, you should make a model, you should make a diagram. The more complete the diagram is, the greater the accuracy the results is. And you have to define the process you are studying and just identify all the inputs: water, gas, electricity, materials, components, transportation, and then define all the outputs, finished parts or components, because only the semi-finished product are to be considered, hazardous materials outputs, and non-hazardous materials outputs, I mean emissions to air and water. And data could come from observation, from quantity research, from manufacturer information, and maybe some of you really knows that is the most difficult phase, just because to collect data from manufacturer is not really easy. And data validity is important. I mean, it's better to use data, primary data, I mean data from manufacturer, than using data from database. Even if database in software, for example, all databases which have been entered in the calculator are really updated. It's better to have and to collect data from the manufacturer, and then if these data are not available, just using database. Again, this is this is a slide that Mr. Cariani used during the kickoff meeting, and this is our this is the data we are going to use. We used to prepare our calculator. So data entry are referring to products, food, energy, buildings, transport, and waste. Then we are going to calculate the emission factors using specific data and generic data. And then we are going to use some kind of indicators which are energy related to try to quantify our impact on the environment. If we are going to calculate carbon footprint, our footprint on environment. And we reached this phase, impact assessment. Just 2 words about it. Impact assessment is the impact assessment should assess potential human and ecological effects of energy, water, and material usage, and the environmental releases identified in the inventory analysis. So we have collected all the data, we have arranged them, and then we have to calculate their impact on the environment. And the impact can be on ecological and on human health. It can have ecological and human health effects. So we are not studying only environmental impact, but also human health effects. It should also address resource depletion. So there are more or less 3 categories: ecological effects, human health effects, and resource depletion. This phase, life cycle impact assessment, attempts to establish a linkage between the product or the process we are studying and its potential environmental impacts. And we have to calculate the weights of the different impact, which is a operation using inventory data and factors of characterization. And this is what the calculator is doing automatically. You put inside the calculator, you enter all the data in the calculator, and then there is some operation, it's not the exact terms anyway, which are characterized factor, and then the calculator gives the impact of our object. The typical impact categories are climate change, stratospheric ozone depletion, eutrophication, photochemical smog, acidification, human toxicity, ecotoxicity, water resource depletion, mineral resource depletion, fossil fuel depletion, land use, biodiversity, and soil conservation. And then we should try to understand, to identify what are the specific impacts on each one of these variables. I mean that all these kind of pollutions makes a different environmental impact, and some of them makes different kind of environmental impacts. For example, CFC can have CFCs have impact on greenhouses effect and on ozone layer depletion. And as you can see, some of them has more than one environmental impact. But there is a software who is doing this one on behalf of us. And when you have the results, you can choose which are the methods you can use to communicate the results, to communicate them to your final customer. And for example, this is a diagram, this which is called spider diagram, and is one way to show how a particular product's environmental effects or footprint are reduced over time through incremental improvements in sustainable design. So as you can see, this diagram shows the dimensions of the footprint in year 29, and this is the area. In year, I said 29, sorry, 20 and 9. And in year 20 and 25, I mean 2025, as you can see, some of impacts will be reduced, others will be similar. And in 20 and 50, if you are going to make some intervention, some actions in your process, inside your process, maybe you should decrease all the impact as you can see in this kind of diagram. The latter phase is interpretation of the results, and interpretation is a systematic technique to identify, quantify, check, and evaluate information from the results of the life cycle inventory and or the life cycle impact assessment. The results from the inventory analysis and impact assessment are summarized during the interpretation phase, and the outcome of this phase is a set of conclusions and recommendations for the study. I mean, we have to interpret the results we achieved, and then identify some interventions, some actions to do to reduce the impact. According to ISO 40040, the interpretation should include identification of significant issues based on the results of the life cycle inventory and life cycle inventory assessment phases, should include evaluation of the study considering completeness, sensitivity, and consistencies checks, and should include conclusions, limitations, and recommendations. I tried to show you some example of existing life cycle assessment, and I'm trying to choose the one that everyone can know. I mean, coffee maker, everyone knows what a coffee maker is. So maybe you don't know, but there is a life cycle assessment about coffee maker. Step one of this assessment, life cycle assessment, as you already know, is a goal definition and scope. I mean, we have to establish our purpose and our goal. I mean, this company established its purpose and its goal. And the goal was to determine how to improve the environmental performance of a coffee maker. The functional unit was total energy consumed, equivalent CO2 produced. The system boundaries was 5 years of use, euro production, use, and end of life stages. So they started from the use phase, the production, and the end of life stages. And then they determine which were the required data, which was the required data quality. So they make process tree, I mean a flow chart, to understand which are the data they have to collect. Then they determine all mass and energy inputs and outputs. And then they establish material and energy balance for each stage and event. And so you can see that here there is a single stage or unit operation. And then they studied all the other phases connected to the single operation one. This is a simplified process of a coffee maker, and these are the phases they have considered. So coffee beans, production of paper, polystyrene, aluminium, steel, and glass. These are the upstream phase, and coffee beans has to be transported and processing. Paper is used to produce filter. Polystyrene has to be injectioned and molded. Then there is the extrusion of aluminium, the pressing and forming of steel. These are the industrial process they have considered. And then there is the forming of glass. All these materials, polystyrene, aluminium, steel, and glass, are used to have to put together and have to transport, have to be packaged, and then there is the use phase. Here there is the coffee maker that needs water and electricity to work. And then there is disposal of coffee and filters and disposal of machine itself and the packaging to transport the coffee maker. The difficulties and limitation of inventory phase was finding data. As you can see, it's the hardest phase because published data on materials loads exists but is often inconsistent and or not directly applicable. And then it was really difficult to obtain data, to obtain static and linear data. They have to make many simplified assumptions, and these assumptions usually provide mistakes in quantification, And then mass and energy balances may not be correct with a lot of assumptions, and then results can be generalized improperly. And this is the amount of polystyrene injecting molding, aluminum, steel, glass, and so on. This is the amount inside a coffee maker. This is the results of indicator. As you can see, the result is the multiplication about the indication and the amount. Then the same for use phase, and I have to accelerate because time is going to finish, and I would like to put your attention about this kind of answer. Where are the impacts occurring? I mean, we are talking about United States, Europe, or Brazil, because the damage relating to the environment impacts are different. Is there damage already in the area being impacted? And how much can that area take before it breaks down? Or can it handle it without any problems? So the results will be different if we are talking about an area or another one. And at the end, we have to decide how to improve coffee maker and where should we focus. As you can see, the size of the figures are related to the quantity of impact, environmental impact. As you can see, the use of electricity in the phase of use are the greatest impacts. This is another example in which cup scores best with our environment, and this kind of LCA makes a comparison between three kind of containers, foam, plastic, glass, cup, and paper cup. As you can see, there is different results, consideration about energy conservation. For example, very high for plastic, needs relatively little energy to make. For glass one, glass cups needs high energy to run kilns and wash for reuse, and paper requires high energy to run mills. And another categories, for example, landfill contaminants, there is no one pollutions for plastic and no one for glass, and paper can contribute to methane gas and leakages. So we reach the conclusion. So now you with me can say that LCA is an invaluable tool where environmental impacts assessment is carried out on various products or systems, and by being able to quantitatively assess the environmental impacts, one can make necessary correction to decrease the environmental impacts and to find a better way to make their product or system. It is then a win-win situation. LCA helps to avoid shifting environment problems from one area to another. Just studying all the chain, we can focus, we can identify which is the worst phase and focus the attention only to our process is a way to shifting environmental products from my area, my company, to another area, and this is not useful. Anyway, we just finish the slide presentation, and you can put your answer if you have it. Thanks, many thanks for your attention.